So today we will be solving exercise 2.2 for inverse trigonometric functions and CRT. Question number 1. So given that 3 sine inverse x have to is equal to, we have to prove this thing, that this is equal to this. Right, left hand side is equal to right hand side, or right hand side is equal to left hand side. So for this we need sine of 3 theta is equal to 3 sine of theta minus 4 sine cube theta. This is the trigonometric identity. So basically we need trigonometric identities. Either we know the trigonometric identities, then we can solve them directly, or you have to do some substitution. So if I take the right hand side, sine inverse of 3x minus 4x cube, and do the substitution, x is equal to sine of theta, which implies that theta is equal to sine inverse of x, right? So using this here, we get sine inverse of 3 times sine of theta minus 4 times sine cube theta. So this will be sine inverse of sine of 3 theta, which is equal to 3 theta, which is equal to 3 times sine inverse of x. This is what we have to prove. Now, moving to the second question. The second question says we have to do for question number second, 3 times cos inverse of x is equal to cos inverse of 4x cube minus 3x. This is we have to show. Again doing the same thing, but this time we'll be using the trigonometric identity. Cos of 3 theta is equal to 4 cos cube theta minus 3 cos of theta. So this is the trigonometric identity. This will be using. Now you do x is equal to cos of theta. X is equal to cos of theta. This implies that theta is equal to cos inverse of x. Now using this here in the right hand side of our question, then cos inverse of 4 times, instead of x I will be putting cos cube theta minus 3 cos of theta. So this will be cos inverse of cos of 3 theta, and cos inverse and cos cancel. Then we get 3 theta and 3 times cos inverse of x. That's what we have to prove. Now for the question number 3, we have to do for tan inverse, which we have to simplify this. We don't have to prove anything, we have to write it in a simpler form. So question number 3, tan inverse of square root of 1 plus x square minus 1 whole thing divided by x, where x is not 0. So how do we simplify this? Now let's put, we know the identity about tan as 1 plus tan square theta is sec square theta, right? This is, let's put x is equal to tan of theta here. What do we get? We get tan inverse of square root of 1 plus tan square of theta minus 1 divided by tan of theta, right? Let's go further. Then we get tan inverse of sec of theta minus 1 divided by tan of theta, right? Since the range of sec inverse for which this is defined, we'll be taking the positive range, tan inverse of sec of theta minus 1 divided by tan of theta. And further simplification, we get 1 minus cos of theta divided by sine of theta. So we get tan inverse of 2 times sine square theta by 2 divided by twice sine of theta by 2 cos of theta by 2. So what actually I did here, I write sec of theta as 1 by cos of theta, then minus 1, this becomes 1 minus cos of theta divided by cos of theta, and I'm changing this tan of theta to sine of theta by cos theta, so the things get cancelled here. Sine of theta by cos of theta. So this is what we get finally. So let's try to do further simplification. Tan inverse of sine of theta by 2 divided by cos of theta by 2. Some cancellation here. Now what we are getting further, tan inverse of tan of theta by 2. This is theta by 2, and our substitution was x is tan of theta. Theta will be tan inverse of x. So final answer here will be tan inverse of x theta is tan inverse of x, and we are dividing that by 2, right? Theta is equal to tan inverse. Now let's move to the next question. So we did question number 3. Let's go to the question number 4. Tan inverse of root of 1 minus cos of x divided by 1 plus cos of x. Let's try to simplify this. Question number 4. Tan inverse of square root of 1 minus cos of x divided by 1 plus cos of x. We have to do the simplification for this part. So tan inverse of square root of 1 minus cos of x, I can write it as 2 times sine square x by 2 divided by 2 times 1 plus cos of x as 2 times cos square x by 2. tan inverse of square root of tan square x by 2, right? So this will be tan inverse of absolute tan of x by 2. This will be tan inverse of. So if we look at the range of tan of x by 2, we are considering the positive part of this. So this will be tan of x by 2, which is equal to x by 2. The final answer will be x by 2. So here we are considering the parts where function is defined, tan inverse is defined, and so the positive part has to be considered. So now let's move to the next question. X was between 0 to pi, right? Now question number 5. So for question number 5 says tan inverse of cos of x minus sine of x divided by cos of x plus sine of x. We have to do the simplification. Let's do it here. Question number 5. Tan inverse of cos of x minus sine of x divided by cos of x plus sine of x. We need a simplification for this. This we can write as tan inverse of, if we divide cos, then this will be further simplified in this form, right? I have divided cos to all these terms by the cos of x. We get this. I can write this in terms of tan pi by 4 minus tan of x 4 divided by 1 plus tan pi by 4 tan of x. We know that tan of pi by 4 is 1. So here I am putting tan pi by 4 and I am also multiplying that with, so it's 1. This will be tan inverse of tan of pi by 4 minus x. So we know that tan of a minus b takes this form. So if we cancel these two things, we get pi by 4 minus x, the simplest form of this. Now question number 5 we did. Let's do question number 6. So question number 6 is tan inverse of x divided by root of a square minus x square for mod of a x less than a. Question number 6. Tan inverse of x divided by square root of a square minus x square for mod of x less than a. So here we can do the substitution. If I put x is equal to a sine of theta, I want to make the internal part some function in terms of tan so that I can do the cancellation. Now a square minus x square will be a square minus a square sine square theta, which is a square times 1 minus, which is a square times 1 minus sine square theta. This will be a square cos square theta. So tan inverse of x divided by root of a square minus x square. This will be tan inverse of a sine of theta divided by square root of this will be a cos of theta, then this will be tan inverse of tan of theta, which is equal to theta, and theta we have from here. Theta we can write as theta is equal to x sine inverse x by a. So theta is equal to sine inverse x by a. That's the simplified form for this question number 6. Now let's go to the question number 7. So question number 7, we need identity for tan of 3 theta. Let's first write the question. Question number 7, tan inverse of 3a square x minus x cube divided by a cube minus 3a x square. A cube minus 3a x square. We have to simplify this part. So for this, we will use the trigonometric identity tan of 3 theta. That is 3 tan of theta minus tan cube of theta 1 minus 3 tan square theta. This we should know. This is from these are identities from the trigonometric functions. Since we are dealing with the inverse trigonometric functions, then we should know all these identities. So let's put x is equal to a tan theta. Then 3a square x minus x cube divided by a cube minus 3x square will be equal to 3a square into a tan theta minus a tan theta. Here we have a cube, here we have a cube, and whole thing a cube minus 3a into a square tan square theta. Taking a cube common from all these things, we get 3 times tan of theta minus tan cube of theta divided by 1 minus 3 tan square of theta. So this is the internal part of this, and we know from the above identity this we can write it in terms of tan of 3 theta. So tan inverse of 3 a square x minus x cube divided by a cube minus 3 ax square. This is tan inverse of tan of 3 theta, which is 3 theta, and theta we have tan inverse of 3 times tan inverse of x by a. This is the final answer for this. Now let's try to evaluate this. Tan inverse of 2 cos of 2 times sine inverse of 1 by 2. Question number 8. Here we have 2 here. So tan inverse of 2 times cos of 2 into sine inverse of 1 by 2. This is pi by 6. Tan inverse of 2 times cos of pi by 3. 2 ones are 2, 3s are. This is equal to tan inverse of 2 times cos of pi by 3 is 1 by 2. This tan inverse of 1, which is pi by 4. So pi by 4 is answer for this question number 8. Now for the question number 9, we have to do the simplification for this part. So let's So question number 9 is tan inverse of 1 by 2 sine inverse of 2x divided by 1 plus x square plus we have cos inverse of and some expression in y. So what we do here is put x is equal to tan of theta 1 and put y is equal to tan of theta 2. Then 2x divided by 1 plus x square will be 2 tan of theta 1 divided by 1 plus tan square theta 1. This will be 2 times tan of theta 1 divided by sec square of theta 1, which is equal to 2 times sine of theta 1 cos of theta 1, which is equal to sine of 2 theta 1. Now for this part, 1 minus y square divided by 1 plus y square is equal to 1 minus tan square of theta 2 divided by 1 plus tan square of theta by theta 2. Now if I simplify it in terms of sine and cos, I can write it in terms of cos square theta 2 minus sine square theta 2 divided by uh, cos square theta 2 plus sine square theta 2. This part is cos of 2 theta 2 divided by 1. So if I apply cos inverse of 1 plus cos inverse of 1 minus y square divided by 1 plus y square, this will be cos inverse of cos of 2 theta 2. This will be 2 theta 2. Now I have tan of 1 by 2 inside of which now this part I have solved as sine inverse of sine of 2 theta 1 plus cos inverse of cos of 2 theta 2. This will be tan of 1 by 2, 2 theta 1 plus 2 theta 2. Here we have theta 1 is equal to tan inverse of x, and here we have theta 2 is equal to tan inverse of y. Simplification from this 2 gets cancelled, we get theta 1 plus theta 2. Tan of, we have tan inverse of x plus tan inverse of y. Now, tan of, then we know that tan inverse of x plus tan inverse of y, we can write it as tan inverse of x plus y divided by 1 minus xy. And if we cancel tan and tan inverse, we get x plus y divided by 1 minus xy. So here what I use, tan inverse of x plus tan inverse of y, we can write as tan inverse of x plus y divided by 1 minus xy. This is the identity for tan inverse we used here. So after simplification, we get x plus y divided by 1 minus xy. This was question number 9. Let's go for question number 10. So question number 10, if we swallow here, what question number 10 is saying that sine inverse of sine of 2 pi by 3. So usually what we do, we try to cancel these two things, but we have to be careful that this value is in the domain of sine inverse or any other trigonometric function. So for that, we need to understand, we should know for which range the the trigonometric functions are defined. So let's consider this sine inverse of sine of 2 pi by 3. We know the range for which sine inverse for which the sine inverse is there defined. Its range is from minus pi by 2 to pi by 2. The principal branch is for this part. But this 2 pi by 3 is not here. So how do we change this thing? We can write it in terms of this sine inverse of sine of 2 pi by 3, we can write as pi minus pi by 3. And we know that in the second quadrant, sine is positive. So this will be sine of pi by 3. We get the value pi by 3 for this. Now tan inverse of tan of 3 pi by 4. So is the 3 pi by 4 here in between? No, it's not in between. Again, we will do, this was question number 10. So question number 11, tan inverse of tan of 3 pi by 4. So we cannot directly cancel this uh, because for tan inverse, we have the open interval minus pi by 2 to pi by 2. The range for tan for this is the value which it takes for which the principal branch is defined. So inverse is defined for this part. We can write this in terms of, if we write a bit bigger, this will be tan inverse of tan of pi minus pi by 4. This will be tan inverse of minus tan of pi by 4. So here we should know that trigonometric inverse trigonometric functions tan of minus tan inverse of minus x is minus times tan inverse of x. So we get minus times tan inverse of tan of pi by 4, which is minus pi by 4. So that's the value for this part. Now let's go to question number 12. So question number 12. So for question number 12, we have to find the value for this, and we try to write this in terms of tan inverse so that we can cancel. So here I want to show you that what you can do. There are values like tan of sine inverse 3 by 5 plus cot inverse 3 by 2. Now, how directly we can convert it sine inverse in terms of tan inverse? Suppose this is angle theta, this is perpendicular, base, and height. Then we know that theta can be written as tan inverse of perpendicular by base. This can also be written as sine inverse of perpendicular by hypotenuse, right? So if we have a triangle with base, so from here sine is, this is 3, 5, then this will be 4, the right angle triangle, if this is theta. So I can write directly tan of, instead of sine inverse 3 by 5, I can write tan inverse of 3 by 4 plus cot. We know that we can write cot as tan inverse of 2 by 3. 3 by 2 gets converted to 2 by 3 using these techniques. Now, what we can do here is we can apply the formula for tan of A plus tan of B. So what do we get from this? So we get tan inverse of A plus tan inverse of B. We saw above, this is tan inverse of sum of these things, 3 by 4 plus 2 by 3 divided by 1 minus 3 by 4 into 2 by 3. So after simplification, we get 3 by 4 plus 2 by 3 divided by 1 minus 1 by 2, which is 9 plus 8 divided by 12 into 1 by 2, which is equal to 17 by 6. 17 by 6. So 17 by 6 is for question number 12. So let's go to question number 13. Cos inverse of cos of 7 pi by 6. So here we have 7 pi by 6, pi by 6, pi by. So what will be the answer? So we know that cos is taking the values between 0 to pi, but 7 pi by 6 is greater than this. So how do we cannot directly cancel this. We have to convert this in terms of cos of pi minus pi plus pi by 6. We get cos inverse of minus cos of pi by 6, right? Now we know that this will be, what this will be? This will be pi minus pi by 6, which is 5 pi by 6. 5 pi by 6. So what do we use here? Cos inverse of minus x is pi minus cos inverse of x. This is the identity we use here. So, so the answer will be 5 pi by 6. Now, for the second question number 14, question number 14, what it says that we have to find the value of sine of pi by 3 minus sine inverse of minus of half. So what will be the answer for this? This will be sine of pi by 3 minus sine of minus x. We know that sine inverse of minus x is minus times sine inverse of x. For cos, we get pi minus cos inverse of x. For sine, we get the negative sign comes out. So this is minus times minus sine inverse of 1 by 2. So this is sine of pi by 3 plus sine inverse of 1 by 2. Now we know that this will be sine of pi by 3 plus pi by 6. Sine gets the value 1/2 at pi by 6. So this will be sine of 2 into pi by 6 plus pi by 6, which is sine of 3 pi by 6, which is equal to sine of pi by 2 equal to 1. So 1 will be the answer for this. The last question is question number 15. We have to evaluate tan inverse root of 3 minus cot inverse root minus root of 3 is here, right? So here is the point. Cot inverse of minus x is pi minus cot inverse of x. So using this, we can write tan inverse of root of 3 minus pi minus cot inverse of root of 3. Now this will be pi by 3 minus pi minus pi by 6. So this will be 2 into pi by 6 minus pi minus minus gets plus pi by 6, and we get the answer 3 pi by 6 minus pi, which is pi by 2 minus pi as minus pi by 2. Let me write it clearly. So we get the answer minus pi by 2. And here we have the answer minus pi by 2. I hope it's clear how we solve these questions. So all we need to know is some trigonometric identities, then it gets easier.